video, we are going to see the relation between the numbers, given numbers, and their HCF and LCM. Okay, now what is the relation between the numbers and their HCF, LCM? Now let us see one example. Find the HCF and LCM of 6 and 20. Okay, now for finding that, we can write 6 is equal to 2 into 3 and 20 is equal to 2 square into 5. Now what is the HCF? HCF is the lowest power of the common factor. Here common factor is 2 only. So you have to observe 2. What is the lowest factor? 2. Therefore HCF is 2. Now what is LCM? LCM is the product of the greatest powers of all the factors. All the factors involved are 2, 3 and 5. Then greatest power of 2 is 2 square into greatest power of 3 is 1, and therefore greatest power of 5 is 5. So you are taking 5. Now it is 15. 15 into 4, that is 60. LCM is 60. Now if you observe that, if you take the product of LCM and HCF, let us take product of HCF into LCM. What you will get? HCF is 2 into LCM is 60. You will get 120. Okay. Now take the product of the number. Product of numbers. And numbers are, what are the number? 6 and 20. Therefore product of number is 6 into 20. It is again 120. And this is applicable for any numbers. When the two numbers are given, their product of HCF and LCM is always equal to the product of that given two numbers. So we can generalize this. If A and B are two numbers, obviously we are dealing with the whole numbers, then HCF of A and B into LCM of A and B is equal to always A into B. Means here one number will be there, here one number you will get, and this is the product of two numbers. Now out of this 4, if 3 are given, you can directly find the fourth one. Means suppose you have given HCF of two number is 4 and two numbers are also given, then you can find LCM by LCM. How can you find? LCM is equal to A into B upon HCF of AB. If you want to find HCF, then what HCF of A and B, what you can write? A into B upon LCM of AB. Like this you can find. Okay. Now we will see some more examples. Now let us see one of the example for the relation between numbers and their HCF, LCM. Okay. Now if the HCF of two numbers is 145, means you have given that the HCF of two number is 145 and LCM is 2175. Okay. One number is also given, that is 725. Find the other number. Now you have given two numbers, one of them is 725 and their HCF is given and LCM is given. Now for solving this problem, let A be the number. Okay. Therefore, you know that product of the number is equal to HCF and LCM of that two number. Therefore, A into number, second number is 725 because one number is 725. 725 is equal to HCF into LCM. Okay, HCF is what given? 145. Just put the values. LCM is given 2175. A into 725. So what will be the A? A is equal to 145 into 2175 divided by 725. Now if you observe that and do the calculation, 725 3s are that much. So multiply this to 15, 4, 13 and 4. Therefore, another number is what? 435. Means product of these two number A, that is 435 into 725 is equal to HCF into LCM. That you have to write always this relation for solving this type of question. Let us see another one. It is from the textbook only exercise. HCF of this means HCF, these two numbers are given here. Whenever like this written is there, you have to, this is your A and this is your B, and HCF of this both number is also given. So second is HCF of 306 and 657 is equal to 9. Means HCF is given 9 and your numbers are these two numbers. Okay. Therefore, A into B is equal to HCF into LCM. Okay. Now HCF is 9. You want to find LCM. Okay. Now A is 306 and B is 657. How to find then LCM? LCM is equal to 306 into 657. After dividing by 9, it is 73. Now multiply by this, you will get 2, 2, 3, 3, 8. Find the LCM and HCM of following numbers. Verify the relation of LCM into HCF is equal to A into B. Means that A and B are two numbers. This I previously explained how to do this. For example, suppose take the example, two numbers are given that 26 and 91. That is means A is equal to this and B is equal to 91. Now you have to find the HCF, LCM, and then you have to verify this relation. Okay, so let us find the HCF. HCF of 26 and 91 we are going to find. Before that you have to find the prime factorization. Therefore 26 is equal to 2 into 13, you know, and this 91 is equal to 7 into 13. So HCF is what? HCF is equal to 13. LCM. What is LCM? LCM of this two number is this 13, this common 13 into uncommon all, that is 2 into 7. So after multiplying it will be 182. Okay. Now you have find, you know the A and B and you know the HCF and LCM. That is 26 and 91. Okay. Now I will take the product of A into B. That is 26 into 91. And again I have to take HCF into LCM. Now HCF is 13 and LCM is equal to 182. Find the product of this. I think this product is 23 and 66. That is 2300. And this product is also this. From this, the product of A and B is equal to product of HCF and LCM. And this is how you have to verify the relation. And after writing this, therefore A into B is equal to HCF into LCM verified. This is how you have to write. Okay. Now let us see the another example, and that example is generally asked for the 2-3 marks. Now let us see this example. This type of example is generally asked for 2 marks. Okay. Check whether 6 raised to power n can end with the digit 0. Means check whether means you have to check either that this number can end with 0 or not for any natural number n. For any natural number n. मतलब आपको ये बताना है कि 6 raised to power n ये नंबर इस फॉर्म का नंबर 0 से एंड होता है या नहीं. For that you should know that कि any number which can end with the 0 means that number should divisible by 10. Okay, that means the prime factorization of that number should contain 2 and 5. If the prime factorization of any number contain 2 and 5 as their prime factors, then only that number can end with the digit 0. This you have to keep in mind. Okay, so for that how to proceed this question. Now take, let 6 raised to power n. Now do the prime factorization of 6, that is 2 into 3 raised to power n. Apply the exponent rule, that is you can write it 2 raised to power n and 3 raised to power n. Okay. Now if you observe that the prime factorization of 6 raised to power n doesn't contain 5, because for ending with digit 0 there should be 2 as well as 5. Here only 2 is there, but prime factor 5 is not there. So write that as prime factorization of 6 raised to power n does not contain 5 as a factor. Therefore 6 raised to power n will not end with digit 0. This complete you have to write for the 2 marks. Don't skip any of the step. Suppose here 4 raised to power n is asked. Then now you know that. What is the prime factorization? 2 into 2 raised to power n. Again here 5 is not as a factor, prime factor of 4 raised to power n. Same thing you have to write here. And this statement you have to write. Okay. Now let us see another type of example which is asked for the 2 marks. Now let us see this example. Here one expression is given and you have to show that this number is composite. And what is the composite number? Composite number should have more than 2 factors, means other than itself and 1. So let us simplify. You can do in various method. So which is the better one and which is the easier one I am telling to you. It is 7 into 11 into 13 plus 13 this time. Okay. Here 13, that is can be written as 13 into 1. Use the distributive property. Okay. 13 can be taken common. So what is remain here? 7 into 11 plus 1. Why I have written 13 into 1? Because we are taking the common. This is the plus sign. Okay. From this is the one term and this is the another term and you are taking 13 common. Now it is 13 into 77 plus 1. 77 plus 1, that is 13 into 78. Means whatever this number, okay, is equal to the product of other 2 number, that is 13 into 78. Means this number have 4 factors here, that is 1 itself, 13, 78 and that number whatever will be the value after calculation this. So as this number, as this expression has more than 2 factor, as 7 into 11 into 13 plus 13 has more than 2 factors, this means that this number is a composite number. Okay. Hope so you understand this topic. Now let us discuss the word problem from the exercise 1.2. That is, there is a circular path around a sport field. Sonia takes 18 minutes to drive 1 round. Okay. And Ravi takes 12 minutes for the same. Means वही ground को रवि को चक्कर लगाने को 12 minutes लगते हैं. Suppose they both start at the same point and at the same time. They have started from the same point and at the same time they have started running. Okay. So go the same direction and they are going in the same direction. Okay. After how many minutes will they meet again at the starting point? After how many minutes they will meet the point? So for this, this type of example already you have done in 9th and 8th standard. If they are starting with the same point and for the same time and in the same direction, that will you have to find their LCM. And the LCM, at the LCM they will meet at the first point. Means in that example what you have to do? You have to just find the LCM of that 18 and 12. After that many minutes they will meet it again. Hope so you understand this. You have to solve this exercise in your notebook. Thank you.